Welcome to Study Loop.
So essentially here we have we can draw the system. A mass here, a mass here, a mass here, and a mass here. They're all connected. And this horizontal line would represent the axis of rotation. So essentially, this would all be M, axis of rotation. And so given this, for part A, we can use the equation 1026. And using the equation 1026, we can say that the moment of inertia is simply the sum of the masses with their distance r sub I from the axis of rotation. So this would be 4 times each mass is 0.5 kilograms. And the distance from each mass would be the distance from the axis of rotation to each mass, rather, would be 1 meter, a quantity squared. This is equaling 2.0 kilograms meter squared. This would be your answer for part A. However, in this case, for part B, we can say it right here. For part B, however, the two masses nearest the axis are 1 meter away from it, but the two furthest from the axis for part B, we have an r equaling square root. So we're using Pythagorean's theorem, essentially, to find the distance. This would be 1.0 meters, quantity squared, plus 2.0 meters, quantity squared. And so we can say that I, for part B, would be equal to sum of forces m sub I, r sub I squared. This is equaling, rather we can say this is equaling here, 2 times 0.50 kilograms multiplied by 1.0 meters quantity squared plus 2.50 kilograms times 5.0 meters. So essentially we can say that here 5.0 meters squared. But we're not squaring 5.0 meters. I'm just eliminating the square root because the distance here would be squared. So it would be essentially radical 5 squared, but we can just say 5 meters squared. And here this would equal 6.0 kilogram meter squared. This would be your answer for part B. And for part C, we can simply say that because the two masses are now on the axis of rotation, the other two are distance are equaling 1.0 meters plus 1.0 meters. This would be squared, this would be squared, and we take the square root. We obtain that the moment of inertia now is equaling 2 times 0.50 kilograms times 0 meters, because two of the masses are now on the axis of rotation, plus 2 times 0.50 kilograms times 2.0 meters squared. And we find that this is equaling 2.0 kilograms meters squared. That is the end of the solution. Thank you for watching.